Hello everyone. In our last session, we discussed about the FPGA fundamentals and their implementations. We also highlighted that the hardware description languages HDLs are primarily used for designing the FPGA systems. In this video, we are starting our journey into the VSDL by exploring the signals, which are like the internal wirings of an FPGA. Just as the physical wires carrying voltage representing ones and zeros in the digital system, signals in FPGA also convey these logical labels. However, signals can do more than just carry the binary values. The type of information which a signal can carry is determined by its data type. While signals can indeed convey the binary values, they can also represent a range of other data types. For example, using a specific data type called std_logic. Also, signals in VSDL allows more than just binary data types, like for example, integers, booleans, or even the multi-bit basis like a 16-bit data bus. Understanding and defining the appropriate data type for each signal is essential for ensuring the accurate and efficient communication within the FPGA design. As we progress, we will understand that how to define those signals, integrate them into your designs, and using them to develop the efficient FPGA solutions. Before diving into the VSDL, let's cover some basics. So VSDL is not a case-sensitive language, means that the uppercase and the lowercase letters are treated as same. This applies to everything like object names, keywords, and identifiers as well. Keywords, also known as reserved words for the VSDL, have the specific meaning in VSDL and they are used for the special purposes. Identifier, on the other hand, are the names which you assign to your variables, signals, or the VSDL modules. Identifier in VSDL must follow some certain rules, like they must start with a letter and then can be followed by letters or some digits. Spaces are not allowed in identifiers. Additionally, the identifiers cannot be the same as reserved keywords in VSDL. In VSDL, signals are essential for connecting the components within a digital system. They serve as a pathway for the data transmissions similar to the wires in a physical circuit. Like variables in C or C++, signals must be declared before they can be used. This declaration specifies the name and the data type of the signal, allowing it to carry the data between different parts of your designs. There are two examples of how you can declare the signals. The word signal, which is highlighted in blue, is a VSDL keyword. As I said, that the keywords are reserved in VSDL and cannot be used as identifier or the object name. So for example, I cannot define a signal by the name signal because signal is a keyword and it is reserved. You can easily identify those keywords while you are writing your code in the VSDL programming tools because these keywords will be displayed with a different color in editor. Generally, it is blue. Okay, so we write our signal name followed by the data type of our signal. And finally, we end the statement with a semicolon. The data type of a signal is crucial because it defines the type of data which that signal can carry. In VSDL, this can range from simple logical state like 0 or 1 to the more complex types like 16-bit bus or even integers. VSDL provides a variety of built-in data types to cover the many scenarios. But in case these predefined data types don't suit your needs, then you can create your own custom data types. This flexibility allows you to tailor the signal data types to match the requirements of your designs. VSDL signals, unlike some wires you might encounter, don't automatically start with a specific value. When you declare a signal without an initial value, like in your first example, it begins in an undefined state. Think of it like a brand new wire, its state is unknown. However, the second method offers more control. By assigning an initial value during the declaration, like in the second example, you can set the signal to a known state from the very beginning. This can be helpful for initializing your VSDL design and ensuring it starts in a productive way. Assigning an initial value during the signal declaration in VSDL is a powerful tool, but it is important to understand its limitation. So the first thing that you should know that this initial value only applies during the simulations, which are like the test runs of your VSDL code on a computer. It does not affect the actual behavior of the signals when you run your designs on the real FPGA hardware. Since the FPGA does not receive this initial value, the signal will still power up in the undefined state. This can lead to the unexpected behavior in the FPGA compared to the simulation, because the simulation assumed a defined starting state for your signal. Remember this difference, that the initial values are only for the simulation purpose. So you might ask that how do I make sure that my signals are initialized correctly? But do not worry, this is actually very easy to do, and we will discuss those other ways to manage the signals states during the FPGA power up in the later parts of this video. So till now we have explored that how to declare the signals in VHDL, which acts like a digital wires within your FPGA designs. Now we will quickly see that how we do the assignments in VHDL, means how you will assign some values to the signal or how you can connect the wires in the general terms. So this is achieved by the assignment symbol. In VHDL, the assignment statement is not represented by an equal sign as in C or C++. Instead, in VHDL, it is less than sign followed by the equal sign, which serves as the VHDL assignment operator as highlighted in the red. This operator resembles like an arrow which is indicating the direction of a data flow. Like for example here in this expression signal underscore A less than equals to signal underscore B semicolon, the value of signal B will be assigned to the signal A. In the next session, we will be talking more about different types of VHDL data types, which are pre-supported and what information these signals can carry, how to define them, and most important, how to assign the values into those signals. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for the regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.